Welcome to today's lesson. And by the end of this lesson, I expect you to be able to define a linear equation, explain common graph vocabulary, complete a table of values, plot a straight line graph accurately, and also recognize and write equations of parallel lines. Let's begin. So, first and foremost, where do we see graphs in everyday life? We see graphs on weather forecasts. We see graphs on the stock markets, during school results, for population growth, and to show sports statistics. So, what is linear graph? A linear graph is a graph that forms a straight line. It actually shows the relationship between two variables. What are the vocabularies we use when we talk about linear graphs? First, we have variable. A variable is simply a letter representing an unknown number. You can use X, Y, or Z. Linear equation is simply an equation whose graph is a straight line. Coordinates. A coordinate is simply the position of a point written as, in brackets, X, Y. Now that XY is what we call an ordered pair. Next, x-axis. The x-axis is simply the horizontal axis. Y-axis. The y-axis is simply the vertical axis. Origin. Origin is simply the point where the ordered pair is 0, 0. Scale. Scale is simply the interval used on the axis. Now, in understanding linear equation, one common form of a linear equation is y equals to mx plus b, where m is simply the gradient or the slope, which tells us how steep the line is, alright, how far towards the left, far towards the right, far downwards, far upwards a line is. While b is the y-intercepts. This is where the line crosses the x-axis. For example, we have y equals to 3x minus 2. In that linear equation, the gradient there is 3, while the y-intercept equals to minus 2. Now, we will be talking about how to complete a table of values. If we're given the equation y equals to 3x minus 2, how do we complete that table given? The first step is that we will substitute the value of x into the equation, multiply by 3, subtract 2, whatever we get becomes the value of y. Let's complete this table. The first thing we need to do is to simply write the equation, which is y equals to 3x minus 2. Now, when x is equals to minus 2, what will y be? Y will equal 3 times minus 2. Then whatever we get, we subtract what? Disorder minus 2. So 3 times minus 2 is what? Minus 6. And then we have minus 6 minus 2, which gives us minus 8. So when x is equals to minus 2, y will be what? Minus 8. And this particular pair becomes minus 2 minus 8. Then we substitute for x in the equation. So y equals 3 times minus 1 minus 2. What is 3 times minus 1? That is minus 3 minus 2, which gives us minus 5. This ordered pair becomes minus 1 minus 5. Then, when x is equal to 0, y will equals 3 times 0, alright, minus 2. 3 times 0 is what? 0 minus 2, which gives us what? Minus 2. So when x is equal to 0, our y will be minus 2. So here is minus 2, and this ordered pair becomes 0 and minus 2. Next, when x is equal to 1, what will y be? Substituting 1 for x in the equation, y will become 3 times 1 minus 2. 3 times 1 is what? 3. Then we have 3 minus 2, which gives us 1. When x is equal to 1, y is also equal to 1. This pair becomes 1 and 1. And finally, when x is equal to 2, what would be the value of y? We substitute 2 for x in the equation. So y becomes 3 times 2 minus 2. 3 times 2 is what? 6. So we have 6 minus 2, which gives us 4. So the value of y here is 4, and this ordered pair becomes 2 and 4. So for this particular equation, y equal to 3x minus 2. When the value of x is minus 2, the value of y is minus 8. When the value of x is minus 1, the value of y is minus 5. When the value of x is 0, the value of y is minus 2. And when the value of x is 1, the value of y is 1. When the value of x is 2, the value of y is 4. Now, how do we plot our graph? We will use our completed table to plot the graph. So what are the steps in plotting your graph? First, you draw your x-axis and your y-axis. Then you label the axis. When you label the axis, you choose a suitable scale. Alright? Then you plot each coordinate accurately. When you're done, you join the points using a ruler. And lastly, you extend the straight line if it is necessary. So let's use that completed table to plot a graph. Alright, so I have transferred my table to this graph, and as you can see on the graph, I have already plotted my points. Now, I chose a 1 centimeter equals to 5 units scale. That is why you can see 0, 5, 10, 15 on my horizontal axis, which is the x-axis, and the same 0, 5, 10, all right, on my vertical axis, which is my y-axis. Now, if you look at this point closely, this first point here, this is what? The first ordered pair, where x is minus 2 and y is minus 8. Then it's closely followed by the next point, where x is minus 1 and y is minus 5. Then to the next, where x is 0 and y is minus 2. And then to the next, where x is 1 and y is 1. And lastly, the last point, where x is 2 and y is 4. Now, having plotted all the points on this graph, the next thing I will do, like I said, is to draw what? A straight line. And I will not just draw a straight line on this graph, I would what? extend it. So can you see, all right, this linear graph? Now let's go to another example. In this example, we are going to complete the table of values for the equation y equal to 2x plus 1. Let's do that. So if we have y is equal to 2x plus 1, now when x is equal to minus 1, y will be what? 2 times minus 1 plus 1. 2 times minus 1 is what? Minus 2. Then we have minus 2 plus 1, which gives us what? Minus 1. So our first ordered pair is minus 1, minus 1. Next, when x is equal to 0, what will y be? Y equal to, substituting 0 for x in the equation, we would have 2 times 0 plus 1. 2 times 0 is what? 0 plus 1, which gives us what? 1. So our next ordered pair will be, when x is 0, y is what? 1. Now, when x is equal to 1, we need to substitute 1 for x in the equation. So y will equal to 2 times 1, alright, plus 1. 2 times 1 is what? 2. Plus 1 will give us what? 3. So our next ordered pair is 1 and 3. Then finally, we have x is equal to 2. Now we substitute 2 for x in the equation we're given. So y equals 2 times 2 plus 1. 2 times 2 is what? 4. And then we have 4 plus 1, which gives us what? 5. So our last ordered pair for this equation is, when x is 2, y equals what? 5. Now let's plot this on the graph. As you can see on this graph, the spacing is 0, 2, 4, both on the horizontal axis, which is the x-axis, and the vertical axis, which is the y-axis. Now, let's take a look at how I plotted these points. So here, when x is equal to minus 1, y is equal to minus 1. So I plotted it here, in between 0 and minus 2. Then, this point here, when x is equal to 0, y is equal to what? 1. And then, here we have the next ordered pair, which is when x is equal to 1, y is equal to 3. And then finally, we have this point when x is equal to 2, right? Y is equal to 5. So, what's the next thing I want to do? Next thing I want to do is to draw a straight line across this point and to also extend it, like our steps said. So let's do that. As you can see, the straight line has been drawn, and this completes what? Our linear graph. I'm going to treat a last example on this. Now for this question, we are going to be solving the equation y equal to x plus 4 for x range of values minus 3 to 3. So let's write out the equation. Equation is y equals x plus 4. So right, so when x is equal to minus 3, y will be what? Alright, so minus 3 plus 4, which gives us what? 1. So our first ordered pair here is 3 and 1. Next we have, when x is equal to minus 2, y will be minus 2 plus 4, which gives us what? 2. So our next ordered pair will be minus 2 and 2. Next we have x is equal to minus 1. So y will be minus 1 plus 4, which gives us what? 3. So our next ordered pair will be minus 1 and 3. Then we have x is equal to 0. So y will be 0 plus 4, which gives us what? 4. So our next ordered pair will be 0 and 4. Then we have x equals to 1. Y will be what? 1 plus 4, which gives us what? 5. So we have 1 and 5. Then we have x equals to 2. So y will be 2 plus 4, which gives us 6. So our next ordered pair will be what? 2 and 6. And then finally, when x equals to 3, we would have y is equal to 3 plus 4, which gives us what? 7. So our next ordered pair is what? 3 and 7. Now, let's plot all these coordinates we have gotten on our graph. As you can see, I have already what? Plotted my coordinates. And the scale I chose is 1 unit is equal to 5, both for my x-axis and for my y-axis. Alright, so let's see how I plotted each of the points. So this is the first. Here, alright, x is equal to minus 3 and then y is what? 1. Then we have the next one. X is equals to minus 2 and y is equals to 2. Then we have the next one. X is equal to minus 1 and y is equal to 3. Then we have the next one. X is equal to 0 and y is equal to 4. Then we have the next one. X is equal to 1 and then y is equal to 5. Then we have the next one. X is equal to 2 and y is equal to 6. And then the last one. X is equal to 3 and y is equal to 7. So let's just look at them at a glance. Okay? Alright. So this is all these points on this table plotted on this graph. Now what I want to do next is to draw my straight line across this point and even extend beyond it. So let's do that. Alright, so can you see my linear graph? Now let's talk about parallel lines. What are parallel lines? Parallel lines are straight lines, 1, that never meet, 2, that have the same gradient slope, and 3, that have different y-intercepts. Now, how do we get possible parallel equations, alright, to certain equations? The rule is simply to know that the parallel line will have the same x number as the original equation. The only difference is the last number. So if the original equation is y equals to 3x minus 2, the possible parallel equations could be y equals to 3x plus 4. Can you see that it retained the x number but changed the last number? Then we have other possible examples like y equals to 3x minus 7, y equals to 3x plus 10. So like I said earlier, the gradient is simply the steepness of a line, right? I already explained that parallel lines are lines with the same gradients that can never what? Meet. Then your intercept is simply the point where your graph crosses an axis. The coordinates, I have already said, is the position of a point on a graph. Then your scale is the equal spacing you used on the graph. While your variable, like I said previously, is the unknown quantity represented by a letter X or Y. Now, let's apply a parallel line to this other graph that we plotted, the graph for y equals to 3x plus 2. Now look at the initial table of values. Look at the points where, all right, this is where we used our line to join the points. Now, let's now add a parallel line. Let's now add a parallel line to this graph. All right, so can you see it? So this is the linear graph and this is a parallel line. Can you see that both lines, what? They do not meet. They do not cross at any point in time. Okay, so this is what we call parallel what? Lines. Let's do the same for the other graphs. So for this equation, the equation is y equals to 2x plus 1. Now let's make up a parallel line for it. All right, so let's add y equals to 2x minus 6. Okay, so see our initial graph and then look at the parallel line. Can you see that those lines do not meet? Okay, now let's also do the same for the third graph we plotted. Now the equation is y equals x plus 4. Now let's make up a parallel line for this equation. So we have y equals x plus 8. Okay, so do you see where the parallel line, all right, emerged? So this is how to plot your linear graphs, and this is also how to add up your parallel lines on your linear graphs. I will attach to this video worksheets for classwork and assignments, and you can forward it to me in my mail. Thank you for watching this lesson. See you in the next one.